So in this video, we'll wrap up our discussion of Section 3 of SAT Practice Test number 8. So these 5 non-calculator questions are the questions that you have to grid in the answers to on the actual SAT, so there aren't multiple choice options here. I think these questions in general are typically a little bit easier, and we'll try to make some sense out of the ones that we see at the tail end of this. So they give us, in number 16, they give us a quadratic equation. They tell us that A is a solution to the quadratic equation, and they tell us that A is greater than 0. What's the value of A? So let's solve the quadratic equation, figure out which answer is positive. There's our value for A. So if you've looked through the other questions within this section of the SAT, this is probably the 3rd or 4th time that we've had a need to solve a quadratic equation by factoring. I guess I shouldn't say we've had a need to. We could have used the quadratic formula. We could have used completing the square or some other method, but on a non-calculator test, highly likely quadratic equations are going to be able to be solved by factoring, and that is the case here. If I try to factor this, first times first would have to give me x squared, so I picked x and x. Last and last, I need to multiply together to give me negative 12, so I went plus 4 and negative 3. And then the outer multiplication gives me negative 3x. The inner multiplication gives me plus 4x. That gives me plus 1x in the middle. That tells me I factored it correctly. When I solve the equation by factoring, I set each factor equal to 0. When I set this equal to 0 and solve for x, I do not get a positive answer. That is not our answer for this. But when I set this second factor equal to 0 and solve for x, I do get an x value of 3. So A is equal to 3 because they tell us that A is positive, and we are looking for the positive solution to this quadratic equation. Next question here tells us that the sum of this polynomial and this polynomial can be rewritten in this form. It tells us A, B, and C are constants. What's the value of A plus B plus C? So it says to take the sum of these polynomials and get this answer that they indicate on the second line of the problem statement. So I'm going to take the sum. So when I take the sum of these two polynomials, I'm basically just combining like terms. So I've tried to highlight the like terms. Negative 2x squared plus 3x squared is going to give me 1x squared. I have parentheses around this second polynomial just to kind of indicate that I'm adding that entire 3-term expression onto the first. The parentheses aren't really doing anything. If this was a difference rather than a sum, and this was subtraction there, I'd have to be a lot more careful. I'd have to distribute that negative in and just take things a little bit more slowly. A little bit easier when it's addition. I have 1x right here. I'm adding 7x to that. That'll give me 8x. I have 31 here. I'm adding negative 8 to that. That'll give me 23. Now it tells me that A, B, and C are the coefficients of x squared, x, and then the constant term c. So A is 1, B is 8, C is 23. It asks me for the value of A plus B plus C. We'll add those 3 values together, and you get an end result of 32. Have a system of equations that they present us with here. They ask us for the value of y. So they do give us some decimals. There's no calculator in play here, so we're going to have to just kind of take our time and work out the arithmetic with the decimals that are involved. Now they ask us for the value of y. So they don't ask us for the ordered pair x comma y. They just ask us for y. This is actually kind of nice because if you look at what's in front of the x's, a negative 1 is the coefficient of the initial x, and a positive 1 is the coefficient of the next x. If I just add negative 1x plus 1x, I get 0x. I eliminate x, and I can find y pretty easily once that happens. You're not wrong if you choose to use substitution here, or Kramer's rule, or some other method to solve the system. But if I am only asked for y, and I can easily eliminate x, that's going to save the most time and be the quickest route to the end. So I'm adding this bottom equation to the top one in order to successfully eliminate the x's. When I do y plus 3y, that'll give me a 4y. I have to do negative 3.5 plus 9.5. This isn't all that bad, actually. If I subtract 3.5 from 9.5, I actually end up at 6. And then if I divide both sides by 4, I get an answer of 3/2 or 1.5 for my value for y. Normally, you'd probably want to plug that back in, find the corresponding value of x. We don't need that. They just ask us for y. Pop that in, and you're on to the next question. Little story problem here. So they tell us a startup company opens with 8 employees. The company's growth plan assumes that 2 new employees will be hired each quarter for the first 5 years. An equation is written in the form y equals ax plus b to represent the number of employees employed by the company x quarters after the company opened. What's the value of b? This right here, although they don't use the variable m, the letter m for slope, that is slope-intercept form with a replacing the m. They just ask us for the value of b. They ask us for the starting number of employees, essentially, right? Whenever you have a linear equation and you're trying to find that value of b, that value of b is going to be whatever the number of y is when x is 0. Well, x is 0 when the company is a startup, when it's brand new, right? So that's going to be the value of 8. So the answer here is not the whole equation that I have written out here. The answer here is just the plus 8. 2 is going to end up being the slope, right? We're growing by 2 employees per year, so that's the rate of change. If it asked you for the value of A, it would obviously be 2. Last question in this section gives us a circle. You see the variable x is a certain number of degrees measured from the center of the circle. They tell us that the length of arc BC is 2/5 the circumference of the circle. What is the value of x? So here's what I think when I read that. If b is 2/5 the circumference, I know that the complete circumference is one complete trip around the circle, which I couldn't really highlight very effectively with my mouse. But one complete trip around the circle is the circumference. I'm only going 2/5 of the circumference if I'm only considering this distance, the length of that arc. So that must mean that this angle measure x is only 2/5 of the full number of degrees that the circle possesses. Well, the circle possesses 360 degrees. If I'm trying to figure out what 2/5 of that full amount is, yeah, I've got some uncomfortable arithmetic to try to do here in order to get my answer that I can grid into this last question here. What I did is I took this multiplication, I literally did top times top, bottom times bottom, and then tried to reduce. I could have done 360 divided by 5 and then multiplied that answer by 2. So a few different ways you could get this, but hopefully you understand the strategy. This is 2/5 of the complete distance around the circle, therefore x is going to be 2/5 of the full number of degrees that the circle has.